Welcome back. Well, you've made it through confidence intervals. Let's step it up a little bit to hypothesis testing. Now, it sounds a little bit scary, but let's take it one part at a time, take good notes, maybe take a look at this second time. But we'll get there. Here's a link that you might be interested in if you check on Blackboard and pull out the PowerPoint that goes along with this. All right, here's chapter 7, all about hypothesis testing. I'm going to talk about section 1, 2, and 3 to be tested on those, and extra credit questions might be on section 4 and 5. Now, even though they're called extra credit problems, they actually aren't that hard. If you learn 7.1, 7.2, and 7.3, 7.4 and 7.5 are really just extensions of that. You've worked with proportions before, like 77% of the population is blah, blah, blah. Or the standard deviation of the population height is whatever. That's all familiar with you. All you have to do is extend that using a couple of extra definitions, and you'll be on your way. So I challenge you to do that. Here are the objectives. So you might pause and take a look at these. We'll talk about every single one of them. All right, first of all, hypothesis test. We're not going very far unless we know what a hypothesis test is. The testing itself is a process to test a claim. A claim is just a statement. We're saying what we think about the value of a parameter, the value of a mean, proportion, standard deviation. What does the claim say? That's where you'll start all of these. What are they saying? For example, you've got a manufacturer that says their hybrid gets a mean gas mileage of 50 miles per gallon. You know what a mean is. You know what 50 miles per gallon is. But suppose you think that the mileage is not 50 miles per gallon. How would you show that's false? Well, we're going to get there. So the hypothesis is a statement about a population parameter, right? Oops. Then, what you want to do is carefully state a pair of hypotheses, starting with a claim, of course. What is the claim? Read through the paragraph or sentence or whatever it is and find out what someone is saying. Second, you want to write down what is its complement. Complement. What does complement mean? It means what's the exact opposite of the claim. These two are going to be exact opposites. That's important because they're exact opposites and one is the complement, that means one of them will be true and one of them will be false. If one is true, the other is false. If one is false, the other one's true. There's no middle ground. That is very important. And that's just what I said. Now we're going to call them the null hypothesis and the alternate hypothesis. And the alternate hypothesis might represent the original claim, but that's not something you have to be concerned about. We're going to work with it either way. The null hypothesis is the one that has equals somewhere in it. See the equals at the bottom of this one? And there's equals itself. There's equals at the bottom of that one. So if you have a hypothesis and it has one of these, then it's going to be called the null hypothesis. And this right here is a 0, or null as some people would say. The alternate is just the opposite. So if you take the original claim claim, and we'll just say the opposite of the claim. Write those in math terms. For example, mean is greater than or equal to 7. If that's the claim, then the opposite would be the mean is less than 7. Notice that if you look at those two, there are no other possibilities. If one of those is true, the other one has to be false, and vice versa. So all you need to do is get the claim, write out what the claim is, what the opposite is, or the complement, write them in math terms. The one that has an equal somewhere in it is going to be your null hypothesis. And by default, whatever the other one is will be your alternate hypothesis, H sub A. So in this case, our null hypothesis would be that the mean is greater than or equal to 7 because it has equals in it. The alternate hypothesis would be just the opposite, the other statement. The mean is less than 7, and you're ready to go with your hypothesis testing. One extra note, just in case you should take another statistics class at some point. So where's my mark? There we go. This alternate hypothesis is sometimes written like this with an H sub 1 instead of an H sub A. These represent the same thing. Your book uses this notation. That's what we'll stick with. So, H sub 0. H sub 0, or you can call it H naught if you like. You might call it different things if you're in different countries even. The H sub A, and usually we'll use a capital letter, that way we can tell for sure that it's an A, and it's H sub A, and just write it like that. Make sure the A is smaller in the subscript. Now, state of the hypothesis. To write those, you need to translate the claim. So we always start with the claim. What does the claim say? And how can you write it in a mathematical statement? So claim, you're going to convert that to a math statement. Then you're going to write the opposite. Whatever this is, you're going to write the complement. Notice there's an E there. The complement is the exact opposite of the statement. Now you'll have two math statements, and the one that has an equal somewhere in it will be the null hypothesis. Very easy. So you start with the claim, write its opposite. Then you set them up. The null is the one that has equals. The one that's remaining is the complement. It'll be the alternate hypothesis. Like this. Here we've got one of these was from the claim. We don't care which one. We're just showing how to set this up. This is the one that has the equals, so it's the null hypothesis. And this is what remains, and that will be the alternate hypothesis. Again, this one has equals, it's the null hypothesis. And the remaining one is the alternate hypothesis. It's that easy. So either one of these could be the claim. Either one of these could be the claim. You write that, and the opposite, the one that has equals, will go in here. And just like this. Now these two look a little bit similar because they're greater than or less than or equal. This one says just straight out equals. What's the opposite of equals? Not equals. And of course, this one has to be the null hypothesis since it has equals. Once you get your head around that, it becomes simple. It becomes part of what you do. Always assume mu equals k, and we're going to start by we're going to talk about the population mean first. So focus on that, and we're going to assume that mu equals k. Don't worry about that. Understand this, you'll be in good shape. Here are some words you can look for when you're getting your statement. Look in your statement. Does it say greater than or equal to some number? Well, then you write it like this. And because it has equals, it's the null hypothesis. Here are a lot of words that you can use. Get to know these. These should be second nature, however, in changing the English to math language. And the one that has equals becomes what? The null hypothesis. All right, so we're going to experiment with this a little bit, or test what we can do so far. First, you want to write the claim mathematically, because this is sort of a math class. It's statistics, but it's math too. Write the null and alternate hypothesis and identify which represents the claim. In other words, you have the null, you have the alternate, and the one up here has equals somewhere in it. And what you'll do before you go on and do anything else, make a note as to which one is the claim. Let's suppose this first one was actually the claim. Then you'll just make a note of it there. That way you won't forget which one it is, because at the very end, when you write your investigation, you're going to talk about how your answer goes back and describes the claim. Here's an example. A school publicized the proportion of its students, so we're talking about proportion this time, those that are involved in at least one extracurricular activity is 61%. So what is it saying? So first of all, what is the claim? The claim is that the proportion is, so that's equals, proportion equals 61%, and we're going to write it without the percent sign. There's your claim. Second, what's the opposite of that? Well, the opposite of that is the proportion is not 0.61 or 61 hundredths. What's next? Well, we'll collect those. We'll have a null hypothesis. We'll have an alternate hypothesis. Which one of these is the null hypothesis? Well, which one has equals? This one right here. So the null hypothesis is the proportion is 0.61. What's the alternate hypothesis? There's only one thing remaining. You can't go wrong once you've got the one up here, right? And you're ready to go? Almost, except which one was the claim? Go back up here where we started. Oh, it's the one with equals. So this time, the null hypothesis is the claim. We're going to make a note of that. If you do this, you'll be well on your way to doing hypothesis testing, believe it or not. Get this down, practice as much as you can, maybe come up with a couple of examples of your own, test one of your classmates. That's a good way of really getting to understand what hypothesis testing really amounts to. There's your null, there's your alternate. Notice the claim here. Where's my marker? The claim is listed here, so we know what it is. We can come back to it at any time. Let's try that again. This time we have a car dealership, and now it's a mean time. Oh, right away we know we have got mu. The mean time for an oil change is less than 15 minutes. So what's the claim? claim is that the mean time is less than 15 minutes, so less than 15 minutes. Before we go on, what's the opposite? The mean is greater than or equal to. We have to include all possibilities. Mean is greater than or equal to 15 minutes. All right, we've got our pieces. Now we're going to put them together in the way we need to. The null hypothesis and the alternate hypothesis. Which one of these has the equals? Right here. So we'll put that for the first one. The mean is greater than or equal to 15 minutes. Notice I put the units in here. That's so that as I'm working on a hypothesis test, I know that I'm talking about minutes. So I don't lose track of what I'm actually working with. And the other one, the only one that remains, mu is less than 15 minutes. What else do I need to do? This one right here is the claim. So I need to list that down here or note that down here. And I'll be ready to do some hypothesis testing. Got the claim, the opposite, sort them out mathematically, make sure the equals with the null hypothesis. Notice the claim down here. We mentioned what the claim was. So later on in the problem, we can come back here and, oh, let's see, we're talking about the claim. So we'll have to answer our question in terms of what the claim stated. Let's try another time. This time we're talking about the mean life of furnaces. You know what a furnace is, I assume. If not, check it out. Furnace usually is something that's going to warm up your house, warm up you too. Now we're talking about mean, so we might make a note to ourselves, and we talk with mu, the population parameters, what we'd like to know about, and the mean life is more than 18 years. So let's start. Claim. What does it say? We're talking about mean, and it says more than 18 years, so greater than 18 years for the furnace. What's the opposite? The opposite would be the mean is less than or equal to 18 years. All right, we've got our pieces to put together. Now we'll come down here, and which one's the null? We'll look back over here. Which one has the equals? The second one. So we'll put mu is less than or equal to 18 years. And that means then that the alternate has to be mu is greater than 18 years. What else? I need to note which one of these is the actual original claim. Now, some pictures just so you can get a visual of what these hypotheses are doing. These are pictures on the number line of different hypotheses. First of all, here's one where the null, remember the null has equals. This one, the null says it's equal to 0.61. That was our first example, remember? And the alternate was it's not equal, which means the alternate would be here or here. And the null would be just this one. But notice also that if you put these two together, it's the entire number line. We haven't left out any numbers at all. Next, our second example was greater than or equal was the null hypothesis. So we have the equals part here and everything up in that direction. belongs to the null hypothesis. What's left? Everything else is down here. And in our third example, this one we were talking about less than or equal to, and it includes this, and it includes everything in this direction. That's the null because it includes the equals. The alternate is everything else. So remember, regardless of which hypothesis represents the claim, always begin the hypothesis test assuming the equality condition in the null hypothesis is true. So start. You might change your mind later. Start. The null hypothesis is true. And you're going to use your statistics to decide whether that makes sense or not. Do you have evidence that shows that it probably isn't true? Or do your statistics back this up? You have to make one of two decisions. Either you reject the null hypothesis using your statistics, or you fail to reject the null hypothesis. Now here's a good place where you want to stop this video, write down those two phrases, because those are the two phrases you're going to use very often. Every hypothesis test, you're going to do one of two things. You're either going to reject the null, or you're going to fail to reject the null hypothesis. Remembering also that because your statistics are based on a sample, you could make a mistake. But we're going to work with that as well. Here's a small table that gives you an idea of kinds of errors you could have. The type 1 error, type 2 error. The way I keep it straight is this. So you start with a null hypothesis and you say, I think it's true. Now, what you're trying to do well, not prove exactly, show that this is unlikely. Low probability. We've talked about probability before. So we'll start with assuming that the null hypothesis is true, and we'll see if it's possible that we can show that it's unlikely that that was actually true. In other words, you made a mistake, perhaps. So if you remember that you're trying to do this, then if you make a mistake, that is a type 1 error. Type 1 error is when this is true and you actually rejected it. You made a mistake. So null hypothesis, you're trying to reject it. If you do reject it, and you shouldn't have, it's a type 1 error. That's the way I keep it straight. Develop your own procedure for this if you like. That's how I do it. You've got the null hypothesis up here, and you're trying to prove that it's unlikely. Not exactly false, but likely to be false. And if what you're doing here is a mistake, then you've got a type 1 error. Now the opposite would be that this null hypothesis was false and you didn't reject it when you should have. That's a type 2 error. For me, if I know what a type 1 error is, type 2 error is the exact opposite. I would suggest you write those down as well. Eventually, this will all become second nature. But for now, It's new to you, of course. Now let's talk about ground beef. According to well, I'm not sure if this is exactly true, but according to this problem, we say the USDA limit for salmonella contamination for ground beef is 7.5%. Notice that is. And the meat inspector reports that it exceeds the limit. Well, that's the claim. So, claim. Here we go. The inspector claims that the mean exceeds the USDA limit. You're going to perform a hypothesis test and see whether you believe that the claim is true or not. What will a type 1 or a type 2 error mean? Well, type 1 error means you reject the null, but you shouldn't have. And type 2 means you didn't reject it and you should have. In this case, it's very important that we get this right. We're talking about ground beef being contaminated or not. Which error is more serious? So let's let P represent the proportion that's contaminated. So the null hypothesis is it's less than or equal to. In other words, it looks as though the ground beef is okay. The alternate is that it's not okay. It's got too much salmonella in it. Here's a picture. These are this good ground beef here, and this is contaminated. Ground beef. Now, if you think about this, all ground beef will have some contamination. You can't have it perfect. But at what point do you say, we shouldn't be eating this ground beef? And that's where the 7.5% came in from the USDA. So here's a picture. Your null hypothesis was it's equal to that amount or it's less. So it's good ground beef. The alternate is it's not good ground beef. It has too much salmonella in it. So what is a type 1 error? Well, the null hypothesis is that it's less than or equal to 0.75. In other words, you're saying this is good beef. That's your null hypothesis in different words. The alternate says you don't have good ground beef. It's bad. Don't eat this. Now, what does type 1 mean? Type 1 means you reject this, reject, but it is true. In other words, your statement, analysis, let's say, your analysis says we reject this, so that means beef, we'll shorten this to beef bad, but if we made a type 1 error, but the beef was actually good. Well, that's not good either. Well, of course, you don't want to make a mistake. What does that mean for us? We said the beef was bad. Where's my marker? We said this according to our statistics. We made a mistake. That beef actually could have been eaten. rejecting the null hypothesis when it's true. And that's a type 1 error. So the actual proportion is less than or equal to 0.075, which means the beef is safe, but you rejected the null. You said it wasn't good. So you create a health scare, and you hurt the sale for the ground beef producers. Good beef, and your results suggested to you that the beef wasn't good to eat. How about a type 2 error? In this case, this null hypothesis right here is false, which means we should reject it, but we don't, because it isn't good beef, but we say yes, it is. Type 2 error. Now what is the problem with a type 2 error in this case, our ground beef case? It's different for each one. You have to analyze it. So the actual proportion is greater than, in other words, you've got bad ground beef, but you don't reject the null. What are you saying? You're saying that bad ground beef is actually good, so people are buying it. So you're allowing the ground beef to be sold when it shouldn't be. And someone could get very sick or even die because of the mistake. Now, in different cases, the type 1 error might be worse, or the type 2 error, in this case, could be the worst case. You have to decide which error is more dangerous, perhaps, or less desirable. Next, level of significance. This, you've seen alpha before. Alpha will represent your level of significance for your hypothesis test. And you'll choose your level of significance before you collect your statistics. This is the maximum allowable probability of making a type 1 error. So let's say a type 1 error is the one you really, really have to avoid. And you want your alpha, the level of significance, to be small. Notice this is a lowercase Greek letter alpha. Remember, the capital alpha looks like this. The small alpha looks like that. If you set the level of significance small, you're saying you want the probability of a true null hypothesis to be small. In other words, you want to reduce the possibility of making a type 1 error. These are the level of significance that are commonly used. The one you'll see the most is 0.05. And if this type 1 error is critical, maybe it's very dangerous, you might make it 0.01 instead. If it's not quite as critical, then you might even have it as 0.10. Now, the probability of a type 2 error is represented by B, which is the lowercase beta in Greek. However, good news. We're not going to be calculating or doing anything with a type 2 error, but you need to know what it is. A little bit of a reminder. If we're talking about confidence and we're talking about level of significance, this is how they are related to each other. The level of significance equals 1 minus the confidence level. So for example, if the confidence level is 90%, then alpha would be 1 minus 0.90, which would be 0.10. And if you like, you can think of it this way. Alpha plus the confidence level equals 1. Total of 1. So after stating the null and alternate hypothesis, I've shown you how to do that. You'll have to practice though. You have to specify the level of significance. So after you get these hypotheses set up, decide what your level of significance is. Then you take the random sample, and then you get your sample statistics. The statistic that you use that's compared with a parameter, remember, for example, if you're talking about the mean, your sample statistic will be X bar. And that's going to be what you use in your hypothesis test. And that X bar will actually be the test statistic. That's what you're going to use to make guesses about whether that claim is true or not. A test statistic could also be converted to a standardized test statistic, such as Z, T, or this is actually chi-squared down here. Chi-squared. Now, you might not get around to using this because this is something that you'll use in hypothesis testing when you're testing variances or standard deviations. Barring that, you're going to use as your test statistics Z, you're familiar with that, T, or chi-squared if you get that far. That's what you use to make the decision. Make the decision. Oops. Test statistic is what helps you make that decision. And we'll see that as we get to examples. So here are the relationships. And this is just a summary. If this is what you're looking for, you want to know something about the mean, you're going to use X bar as your test statistic to decide whether you're going to reject the null hypothesis or not. If you know the standard deviation, you're going to use a Z test statistic. If you don't know the standard deviation for the population, then you're going to use a T test statistic. If you're working with proportions, and as I found out when I learned this is what you're interested in, this is what you're going to use as your test statistic. And just as a reminder, it's just X over N. How many did you get for this kind out of how many total? And that's section 7.4. You might want to try that. If you're interested in the variance or the standard deviation, you'll use S squared for the variance test statistic, or just S for the standard deviation test statistic. And those are in section 7.5, where you would use the chi-squared test statistic. Now, there are a couple of ways we can do this testing. One of these, and the one that seems to be in vogue right now, according to what I've heard, is the p-value. What does that mean? It means it's talking about a probability. It's the probability of something. Make that G good. And what we're going to do is we're going to find the probability with our test statistic, and we're going to see what the probability of, compared to the value we have in our null, what's the probability we get something extreme or more extreme than the one from the sample data. This will make a little bit more sense when we start actually working with it. This is a heads up on it. So we're going to have 3 types of hypothesis tests. Good news. This is easy. 3 kinds. I don't think you'll have too much trouble keeping these straight. First of all, you have a left-tailed test. And regardless of whether we're going to have this further on the slide, this is what a left-tailed test looks like. There's your standard normal curve. We're talking about the left tail. And using our p-value, we're going to ask, did our test statistic go that far away from what we thought was true? This will be the probability that our test statistic or our actual value is this far away from the standard. Right-tailed test, you might be able to guess, you'll have a probability or a p-value over here. And the third one, well, you think, well, there can't be a third one. Left, right, there's nothing else. You don't want in between, that would be silly. Well, the third one is a two-tailed test. And this one, you're talking about the combined probability of those 2 tails. The type of test depends on the sampling distribution that favors a rejection of the null hypothesis. Now this is going to be pretty easy, but all you have to do is look at your alternate hypothesis, and that'll tell you which one of these you're working with. We'll get to that in just a moment. So when you find where that area is, the alternate hypothesis is going to point you in the correct direction. Here's a left-tailed test. Notice that over here we have the alternate hypothesis. Which way is that inequality pointing? It's pointing to the left. So it's a left-tailed test. Very easy. You get to this point, and when you see which way the arrow goes for the alternate hypothesis, that tells you what kind of test you've got. In this case, where it's greater than some value, we'll have a right-tailed test because this points toward the right. And here's what we call our rejection region. We'll get to that. The two-tailed test, that's when it's not equal. And referring to that alpha, the level of significance, that's going to have to be split between the right tail and the left tail. All right, identifying the nature of a test. So for each claim, state the null hypothesis and the alternate hypothesis. So you go with a claim. You get 2 hypotheses. Then you sort them out. Which one is the null? That's the one with the equals. And which one is the alternate? As soon as you state the claim and change it to math language and state its opposite, the complement, then you can write this down. You're going to sort them out. This is the one that has the equals somewhere in it. And you're also going to state which one of these was the claim, because you'll need that later to write up your analysis. So, is the hypothesis test left-tailed, right-tailed, or two-tailed? Sketch a normal sampling distribution. You don't have to be an artist. Just draw a bell curve. Shade the value for the p-value. the area for the p-value will be determined by which tail it is. So if it's a left tail, you'll shade this in like that. And that's going to tell you where the rejection region is. And here's an example we had earlier, where the proportion of the students involved in one extracurricular activity is 61% according to their claim. So the proportion is 0.61. The opposite of proportion is not equal to 0.61. That means what kind of a test are we going to have? Well, first of all, what's the null and what's the alternate? The one that equals is the first one. So P equals 0.61, that's the null. And the remaining one is the alternate. Which one was the claim? The claim was this one. So we're going to mark that for later reference. So there we are in symbols. There's the opposite in symbols. Notice we put this as the null because the equals belongs there. This is going to tell us what kind of a test. It's not left-tailed, it's not right-tailed, it's a two-tailed test. You'll have two what are called rejection regions. And that alternate is just the opposite. These are complements or opposites of each other. There are no other possibilities. Either it is 61% or it's not. There's no other possibility. Next one, we're talking about the oil changes. There's the null hypothesis. And notice this one was the claim, so we want to make sure we take note of that. Because that's pointing to the left, it's a left-tailed test. And down here, when we're doing some of our hypothesis testing, depending on how we do it, we'll usually calculate a z-score or a t-score, depending on what kind of a test you're allowed to have. And the third one, the mean life is more than 18 years. Good furnaces. There's our null hypothesis. There's our alternate hypothesis. Which one was the claim? This one's the claim. So make a note of that. Since that points to the right, we'll have a right-tailed test. Here we go. And it's over here. Okay, this one didn't come out. My apologies. This should say if the p-value you get is less than alpha, then reject the null hypothesis. If p is greater than alpha, you fail to reject. So this should be less than alpha. I'm going to make a note of that. 35. Okay. That way I can make the change. Here again, we can use this little table if we like and see what we've got for type 1 and type 2 errors. Here's where we reject it. And here's where there's not enough evidence to reject the claim. And the alternate. Now you might want to pause right here. There are 4 things that might happen. This is the wording that is standard. This is the wording that's expected in statistics. If the claim is H0 and you reject it, then this is what you write. There is enough evidence to reject the claim. And you follow that up by a statement talking about the claim and what that rejection means. If the claim is H0 and you fail to reject it, then this is what you'll say. There's not enough evidence to reject the claim. It gets a little bit picky, but if you write these down, you can put in the correct wording or the best wording. If the claim is this one, and we reject the null hypothesis, there's enough evidence to support the claim. It doesn't prove the claim, it supports the claim. And in the last one, there's not enough evidence to support the claim. Write those down. Keep them with you. Put them on a special sheet of paper, because some of the wording is sometimes hard to remember, but it's important so we can all talk in the same language. So let's perform a hypothesis test. How would you interpret your decision if you reject the null hypothesis? Remember what the null hypothesis was? The null hypothesis was the proportion is 0.61. If we reject that, we're saying there's enough evidence to reject the claim. And again, here's the wording. There's enough evidence to reject the school's claim. Notice it's about the claim. So you're going to write this sentence, where am I? You're going to write this sentence in terms of what the claim is. Write some of these out so that you have something to build on when you get to your own hypothesis testing. If you fail to reject it, there's not enough evidence to reject the school's claim. The second one, if you reject the null hypothesis, what's that mean? The claim is supported by, or it's represented by H sub A, or the alternate hypothesis. The mean time for an oil change is greater than or equal to 15 minutes. If you reject it, there's not enough evidence to support the dealership's claim. And finish that sentence out. Good words. Keep them with you. If you fail to reject it, this is how you want to write your answer. There's not enough evidence to support the dealership's claim that the mean time for the oil change is less than 15 minutes. That will do you well. Hold on to those wordings. So, steps. State the claim mathematically and verbally. Well, you'll see it verbally, and you'll convert that to math. Second, what isn't mentioned here is state the complement. And in math terms. The one that has equals will go here. The one that doesn't have an equals will go here. Next, specify what level of significance. How important is that type 1 error to avoid? Usually, you'll see 0.05, but you might see 0.01 if it's critical, or 0.10 if it's not quite as important. draw a picture. Once you draw the picture, where is the rejection region? What kind of a test do we have? Right-tailed, two-tailed, or left-tailed? Calculate the test statistic. Standardize it and put it in your sketch. Does the test statistic end up, where am I? Does the test statistic end up in here, or does it end up in there? And this will give us the p-value. If this is our standardized test statistic, z in the first cases, and this will give us our p-value. And remember, back in chapter 5, we talked about getting probabilities of areas. Same thing. This will help us finding the p-value. That's why we did that back in chapter 5. After you get the p-value, very easy decision rule. Talk about the p. Is it less than the level of significance? If it's less than, you're going to reject the null. If it's not, then you'll fail to reject the null hypothesis. Finally, and most importantly, write a statement to interpret the decision in the context of the original claim. So when you finish up your statement, you're going to be talking about what this means in terms of the claim. And the strategy you'll use will depend on whether you're trying to support or reject the claim. Don't worry about that. Don't get caught up in some of these things. Just follow the steps I told you before, and you'll be fine. All right, let's take a look at this before we go. So one of the claims is the mean recovery time. So what I'm going to do is I'm going to sneak in here. Okay, where's my note? There we go. I'm going to be talking about a mean, so it's mu, and is less than 96 hours. So the claim, start with the claim, mu is less than 96 hours. Now how about the null and alternate hypothesis? Well, what's the opposite of the claim? The opposite of the claim is greater than or equal to 96 hours. So what's the null and alternative? Well, let's put it over here. The null, and that's the one with the equals. So it'd be the mean time is greater than or equal to 96 hours. And I put the units in there because that takes me back to what the claim is talking about. And the alternate, the opposite. And how would you interpret a decision that rejects the null? So if you reject the null, then what? You make the guess. Don't make me do it all the time. If you reject that, that means you suspect, according to your statistics, that this might not be true. So you'd actually be supporting the claim. Because remember, this was the claim. That's why you need to have this with an alternate. That way you can write your final result. So think about the context of the claim. That's what it's all about. You want to support the claim, and don't worry about the alternate hypothesis. Just do what I told you, you'll be doing fine. But you do have to use your head, think about what you're talking about, and put it all together at the end with some good words. And you've got some good examples on these slides. Write them down. If necessary, go on Blackboard, copy and paste or whatever, so you get some good wording that you can use through this entire chapter and beyond. just like this. There's your null. Notice the null has equals in it. This was the claim, so you label it as such. So how would you interpret a decision that rejects the null hypothesis? So you're rejecting the null. Where am I? If you reject the null, what does that mean? That means you can't support the claim. We don't have evidence to support the claim. It doesn't mean we prove anything, remember? This is what we would believe, but it's all about the claim though. So we'll be rejecting the claim that the time is less than or equal to 96 hours. Well, that's it, folks. It's taken a while, but I hope you followed it a little bit. You might have to watch it a couple of times and definitely go through and work several exercises. Well, until I see you next time, you take care. Bye-bye.